of the course. Let's look at our lab. So if we go, I'm sure I already have it open. I have too many windows open. But if I go to here, you'll notice that if you go under week 3 now, there are the examples that I went through in class, the code. So you can click on them, see them, whatnot. And then if you scroll down here, we'll see that we covered almost everything. We talked about strings, we talked about lists. We briefly mentioned tuples. Tuples are almost the same as lists, except, I'll just demonstrate this really quick. Let's just pull up this. If I said my values equals, if you use a parenthesis and separate your values, then you've just created a tuple. So a tuple is just a list that looks a little different. You can store the same types of values you store in a tuple. You can store them in a list, and vice versa. But a tuple is immutable. You cannot change the values. Once they're stored in there, they're there. And if you want to change them, you have to create a copy of the tuple and put them in there. So it's really the real difference. And then the other difference is how you create them. So you use the brackets to create lists, parentheses to create tuples. Interestingly, you actually don't even need the parentheses. So you could do something like this. You could say, I'm pretty sure you can do this. My values, let's just see, 1, 2, yes. Technically, you do not need to put the parentheses there. So I just created a tuple without the parentheses. So the parentheses aren't necessary, but they will be printed when you ask for it to be printed. They'll show up. So see how that happened. One of the cool things about tuples is that Python supports assignment by tuples. So you can do something like this. X comma y equals 6 comma 7. And what that does is tuples aren't mutable, but this is an alternative way to create a tuple. You can actually feed it a value. So now if I print X, it will assign it. It has assigned it by, you give it one tuple on one side and a set of variable names on the other, and it's assigned it. The disadvantage here is it's not a sequence any longer, but this was a sequence on this side, and you've assigned it tuple values. So it's a good way to split tuples up. So let's say, well, I have my values still, right? I print my values, 1 and 2. I could say X comma Y equals my values. Now I can say print X, and that's going to be 1. So if you know a tuple's length, you can do something like that. So this happens a lot in what we're going to do in the spatial world. A lot of times there's a coordinate pair, and sometimes, in fact, a lot of times it's expressed as a tuple. Okay, so you can do that in that manner. And so we've got that ability. That's called tuple assignment. Okay, just wondering if there was anything else I wanted to put there. I think I can cover this at a later time. Oh, but tuples can be returned from functions. So remember, functions only return one value. And just like we saw lists return from functions, we can return tuples from functions. So I said functions can only return one value. However, one of the great things about sequences is we can use a sequence to return more than one value. Okay, return more than one value to a user. You do actually, one last thing. my values. Even though it uses a parenthesis in the notation, you still index the items in a tuple by using the brackets. Sorry. My values 1 is going to return the number 2 because it's the second item in the list, in the tuple in this case. And that becomes very useful. You can write functions that will accept a list or a tuple, and as long as you don't try to change the values, it doesn't really matter whether it's a list or a tuple. So somebody could feed it a tuple, somebody could feed it a list, and as long as it does its job, the code can be identical. So the only real difference between a list and a tuple, remember, is that a tuple the values can't be changed in place. Right? All right. And there's a few functions that don't have the ability to be sorted because they can't be changed in place. So why would you sort it? So that's one example. All right. So let's look at the lab assignment because we've actually already done a ton of work for the lab assignment. So we're going to talk more about the how we're going to tackle this problem rather than the specific coding language, because a lot of it has been written so far. We will discuss in a little bit more detail what standard deviation is, so that we all know I do have to go over that last tuple thing here. It looks like because of the assignment, and I forgot, but I'll do that really quick. So let's look at the assignment. Our assignment is to write a simple function that's going to take a list of numbers. We've already written a function that takes a list of numbers, and then optionally another single number using the star function. And it's going to do the following. It's going to check that the list is in fact a list of just numbers. And if not, it's going to return a value of none. Okay. So one way that you could do this is to write a function that would report whether or not the value was a number or not. So you could ask for the type. Okay, basically you can test on the type. If the type is integer or if the type is float, then return yes, it's a number. If not, it's not a number. Okay, and we might be able to demonstrate that real quick. If it's true, it's going to return each of the following as a tuple. So we've had it return it as a list, but we're going to return it as a tuple, which is really the same thing. It's just we're going to use a parenthesis to create our tuple. Okay. All right. It's going to return the sum. It's going to return the mean, and it's going to return the standard deviation. I don't care whether you write one function that returns the sum, one function that returns the mean, and one function that returns the standard deviation, and you call each of those functions, or if you write a single function that returns all three. Okay, you could do either one of those and satisfy the result. So let's go ahead and start this lab by making it return both the sum and the mean based on the code that we've already written. So if I go ahead, and now at this point you could download it if you wanted to. If you went to example 3, that's where we're going to start from. Okay, because value 3 already finds the mean, and we got rid of the sum, didn't we? Okay. Well, we could just modify our function so that it finds both, and it returns a tuple. All right. So let's start by decluttering. Actually, I'm going to start by saving this as Raber_George_. This is the third lab assignment, and then it's the first question in the third lab assignment. So Raber George 3.1. You can call it what you want. and then hit save. The reason why I save it first is because as soon as I start editing it, it's going to modify it. And if I later wanted to roll back my edits, it would be harder. So what I'm going to do is, based on this function, I'm going to remove everything except for this simple function that finds the mean. Okay, so it finds the mean, and instead of just finding the mean, we want this to find. I'm going to call it find stats. Okay, because it's going to find the mean. In fact, I'm going to write mean equals, because that's what the mean is. Okay, and then I can modify this really easily to get the total. Well, I already have total. I don't really need to. I don't really need to come up with a variable because there's already a total in there. That's the sum. So the sum and the mean are already there. Now, if I want to return those values as a tuple, I simply can go like this: return them in the same order that's listed here. So I'm going to return total, and I'm going to return mean. So now it will return those values as a tuple. And to test that, I'm going to say print find stats, and I've got to make an input list just for a test list. I'll make a test list and come up with values. That's my test list. Your test list can be whatever you want. But now it should run, and it should produce a tuple that has. Oh, I didn't need that. It should produce a tuple that has those values in it. I need to feed it test list, not input list. It needs a test list, needs to go in there. So I'll hit run, and it will run that. And it's created those two values. Here's the sum, and here is the mean. Now, I could change the sum to a float, but it would take care of that automatically. If I had any floating point numbers in there, it will take care of that. So now if I hit run, I run that. Notice that it's created a floating point number for us. So we don't really need to explicitly change that value to floating point, because it'll do it for us if it needs it. Okay. All right, so we can go ahead and check off a function that takes a list of numbers, and we haven't quite gotten here yet, but it takes a list of numbers, and so far it reports the mean and the sum. So the only thing that you need to add to this function is the ability to report the standard deviation and this other stuff. Okay, let's start with the other stuff. Okay, we're going to. We didn't demonstrate this in class, so it's important to demonstrate it now. If I put a star there, whoops. Second, I'm getting the syntax wrong. I think, is that it? All right, I got the syntax wrong. Let's go back to the first page, and I believe the easiest question to get the exact syntax. Every once in a while, I forget the syntax. Yep. Okay. It's the star before. Okay, that's what happened. So put the star before. I run this. I'm still going to get an error, but now it's going to be, oops, invalid syntax. Oh, I still got the star afterwards. Okay. One more time. Okay. This time I get an error, but it's a runtime error rather than a syntax error. Syntax errors cause the program not to run. Okay. So this is the proper syntax. Now what this syntax does is it tells you that the input is actually going to be a tuple, and your tuple can be a variable length. Okay, your tuple might be 0, it might be 2, it might be 5. It could be of different lengths. And so what we're going to do here is actually call this, I'll say star t. Okay, star t is going to be the input, and I've told you that you can expect it to definitely have a list as the first element in a tuple. So remember, I said, what type of data types can a tuple and a list contain? They can contain numbers, they can contain strings. Tuples can actually contain lists, and lists can contain tuples, and vice versa. So this tuple, the first element is always going to be a list. So I could change this to say input list equals T0, which means it's going to be that first element. So now this will run just fine. Okay, it's going to run, and it's going to work just like it used to work. Because T is a tuple. In fact, if I print T right here, run it, it's going to show me, see what it does there? It tells me T is a tuple. I know it's a tuple because it's got a parenthesis that contains a list and nothing else. It's just a list. Okay, it's a list. The reason why it has this comma here is so that you know that it's a tuple, but there's nothing else in the tuple. In fact, I can say, I can ask for the length of that tuple, and it's going to say 1. The length of that tuple is 1. There's only one thing in that tuple. Or sorry, len. That's what I meant to say. Yes. Let me put this over here. Is that what you're saying?
Yes.
Yeah. Okay. So the length of that tuple is, I still need to print it. Okay. And I'll slow down a bit. I think I was going too fast. Okay. So the length of that tuple is 1. Okay, there's only one thing in that tuple. The cool thing that this star allows us to do is to give it as many numbers as we want. See, I could give it 5, 7. I can have as many inputs as I want now. Okay. See, I put all those additional inputs. In fact, I could put in something like George. Okay. So now I've fed it a bunch of information. That's what this star does. It says the input is going to be a tuple, and the tuple can be of any length. So now if I go and run this, I'm going to get, it's going to tell me there's 8 values in that tuple. Okay. So if you go back and look at what you're supposed to do, if there's a second number in the tuple, you're going to do something. If there's not a second number in the tuple, all you're going to do is calculate the sum, the mean, and the standard deviation. If there's another item in the tuple, the input tuple, you're going to count how many values are larger than that. In fact, all you're going to do there is the get value thing that you did before. If we look at let's go back to the assignment here. I'm going to sneeze in a second, I think. Excuse me. You're going to return the number of values above that given value. So let's open up the Python again. All right, so all we need to do is say if all these extra numbers can be there, but they don't need to be there. Really, we're just going to say if the number is, if the length of T is greater than 1, whoops, then you need to do something. And I'm just going to put a comment there. I'm going to say find the number of values greater than X. Okay. And really, x is going to equal, how we're going to find x. X is going to be the second item in that tuple. So it's just going to be T1, okay? Because we index the second item by saying 1. The first item is 0, second item is 1. All right? Luckily, we already wrote a function that's going to do this. Okay? So all we need to do is find that function again. We put it, I think the fastest way to get to it now would be to go back to the lab assignment, go to week 3. In example 3, I deleted it. I shouldn't have deleted it, but what do we call that one? Count large. Okay, Control C, move it back over here, and we have another function. And it's okay to call a function from a function. So now we've got this function that's going to count the large numbers, and we're just going to call that function from this function. So it's called count large. And we're going to feed it we said the input list, but it could be a tuple too. So we're going to feed it T0, and we're going to give it the count large, which is X. We could also, we'll just eliminate X, but we could just put T1 there. So we could say large numbers equals count large, like that. Okay. So now when we run this, it's not going to do anything different yet, but let's just see if it causes any errors. Input list is not defined. Where is that? What line is that on? For value in input list. Oh, yeah. So input list here has got to be defined. Input list is equal to T0, the first item in that tuple that's coming in. Okay, now this will work. Run. Okay, so we could see from here that we're still getting the same response. If we want to append on a large number, we can. We just write large numbers. Okay. The only problem is this will work. We put large numbers. So there's 4 numbers that are over 5. The only problem is if we deleted this, now it's going to fail because it's going to say, well, large number doesn't equal anything. Okay. All right. So how might we solve that problem? Okay. We want it to report this large number. If it did this, we want it to report the large number. If not, if we didn't do that, we do not want it to report that. Okay? So we say if something happens, we want it to happen. If something else happens, we don't want it to happen. So we could do something like this. We just say if, because it's an if statement, if large numbers and then finally, else, let's see if this works. Else we want to not return large number. Let's see if it works. Run. Okay. So yeah, that worked. And then let's see if it works in the other case without that number there. It doesn't work. So that didn't work. All right. Why did that work? Let's look at the error. The error says local variable large number referenced before assignment. In other words, large number doesn't exist yet. You didn't assign it a value. Okay. There are probably a few ways that we could overcome this problem. I didn't introduce this yet, but let's see if this works. Equals, sometimes this works. Cancel. Say does not equal 9. Yep, that doesn't even work. Because it doesn't equal anything yet. But what I was thinking is the best way to do this would be to initialize large numbers with a value. We could create a value for large numbers and make it some ridiculous value like 0 or -1. -1 would be a good one because large numbers will never be less than 1. So now we could just say if large number is less than 0, sorry, greater than 0. Actually, say greater than -1, because sometimes large numbers could be 0. Then report it. Okay. So now it'll work. Or if we put 5 back there, it'll return only those numbers that were greater than 5. See that? So now we successfully put an if then statement in there and counted the large numbers. All right. So we've done all that. I did have to reintroduce that concept of that's called gathering. Okay? Gathering is the concept of using that star notation to say I want my input to be a tuple, and it can be as long as you want, and my function will handle what to do with the inputs. All right? Okay, so we handled that. In here, in our function, we took care. We said, okay, well, if it's greater than 1, do this. Modify large numbers. If it's less than 1, in other words, if the length is 1 or 0, just run this code. Okay. So that's that. All right. Now let's talk about some programming, because we have a few other things to do. But all of the rest of the functions will in fact build like this did. And I don't believe there's any other additional new concepts. We'll read through them and make sure here. But we're going to return the standard deviation too. So let's go ahead, and in the code, we're going to have to return stdev. We'll just call it stdev. That's going to be a variable. stdev. You're gonna type the code up that'll create stdev. Stdev. For now, we're going to say it equals 0. We don't know what it's going to be, so you're going to have to write code to calculate stdev. All right. We're going to calculate stdev as being, what is stdev? It is the sum of each number in the, sum of this. I'll just write it like this. Sum of each value minus the mean squared. So I'll just write it like that. Sum of each value minus the mean squared. And then what you do is you take that total sum. So let's say this equals x. Then you take x and you divide it by the count, length, let's say the length of the list, input list, minus 1. And this should be in a parentheses. Okay. So in order to come up with a standard deviation, you could write a function that does this yourself, or you could include it in this function. Okay. But you will have to write another loop. The reason that you have to write another loop, you have to go through this same data again. And each time through, you're going to be calculating up not the sum, you're going to be calculating out the sum of the differences from the means, or the sum of the squared differences from the means. Oh, one other thing is this has to be the square root of that divided by this, like that. Okay, so it's the square root of that sum divided by the number minus 1. That's the standard deviation. So first, the task is to come up with this value. So this value, you basically could take this code right here, that code right there, Control C, Control V. And then what I'm going to do is say, right, I'm going to say modify total to be X above. Instead of total equaling the sum, it's going to now equal, each time through, it's got to be the value minus mean. In fact, and then let's get rid of this line right here. It's got to be, instead of, I'm just going to leave this like this because you've got to modify this. I'll put a line like this so that you'll know this is what you got to modify. Everything between here and there. You got to change total so that it doesn't equal the sum anymore. It's actually this. Each value minus the mean squared. So total is going to be total plus this written in, now we call this pseudocode. This code won't actually run. You need to modify that to be something like value minus the mean squared. You have to put it in parentheses to get it to work. Okay. If you want to test to see if your code works, you can like put it in Microsoft Excel. Put the same numbers in Microsoft Excel, and I mean, if it runs, then you can see if it works. If it doesn't run, then the reason why your code didn't work is because you entered something wrong. So for example, here, maybe if you have a scientific calculator, it'll do standard deviation for you, but you could go like this and say equals stdev here. That's the standard deviation of those numbers. Okay. The standard deviation, what it is a surrogate for the spread. Okay. It calculates the average squared distance from the mean. Roughly. Okay. So that's one thing that you need to do to finish this. And I'll go ahead and save it, and I'll upload that code that you need to upload. That's one thing that you need to do to finish it. In fact, 1.1 will be done after you do that. Okay. Because I'm already testing the values at the bottom. Okay. I'm testing it. So all you're going to do is write a program that tests your function. That's what this is doing right here. Right here, you're testing it. Right. So all you have to do is modify this to calculate the standard deviation, and you'll be done with 1.1. Okay. All right. So we did get pretty far on that one. Let's talk about the next one. So the function included with this lab uses an external module to find the latitude and longitude of a city or address. Okay, it's just a function that that we'll actually walk through what it does because it's only 4 lines of code. The input is Hattiesburg, Mississippi, and the output is the latitude and longitude. It's pretty cool. It's just a function that does that. Now you would think that would take more than 4 lines of code, and it actually does. So we'll explain that in a second. And what you're going to do is modify the program from last week to take a list of cities, like Hattiesburg, Mississippi, whatever, and then it's going to report the total distance along the path that was traversed. And so it'll be pretty straightforward. If you finish the last week's lab, all you have to do is feed your list into your custom. We'll talk about how to do that here. Okay. So what did the program last week it took in x and a y, right? Or latitude and longitude, latitude and longitude. That's what it took in, okay? So you need to modify it so that it basically calls your function multiple times. And instead of using raw input, it's just going to call your function for each time through list. So you're going to write a for statement. Each time through this for statement, it will call your function for last week. So we'll actually take it to that point. Here, let's create a new one. File, new window. I'll put this one over here. And I think what I'll do to start off this is actually copy the code from example 2. Or sorry, no, from week 3, example 2. Here we have our list of cities. In fact, that's enough. Okay. All right. Okay. Well, let's add one more city in here because what do I add? Irvine. You can do whatever cities you want as long as it'll work. And let's start by calling the function that I wrote. So first I'm going to save this. Save as week 3 here. This will be Raber underscore George 3.2. Okay. All right. So cities is going to be equal to this list, and we're going to turn this list into a number of coordinate pairs. Okay. And that's really the first step. But in order to do that, we need to look at the function that I wrote for this week, and that's under location. Location.py. This is a really simple function. Let's look at what it does. It imports 2 functions, one called math, which I don't even think we use, but you'll need math in your program anyway, because that'll be the way, because you needed that last week when you did the function between 2 latitude and longitude, the distance between 2 latitude and longitude points. Because what we're going to get here is latitude and longitude points, and we're going to feed that into your other script. Okay. The other thing that this the other module this thing imports is called URL-lib. And what URL-lib does, it's a module that allows you to make requests over the internet. This is pretty cool. You can load a page from the internet right into your Python code. So we don't have the code actually on our computer that will give us the latitude and longitude of Hattiesburg, Mississippi. That's not the code we have. Okay, we have code that will allow us to call a service that exists. And in fact, this is the service that it's going to call right here. I'm just going to cut and paste this to show you an example. If I cut and paste this, it doesn't have anything. What I have to do is feed this URL some parameters. It looks like address. If I say address equals Hattiesburg space MS, I press enter, it gives me, in fact, I don't even need the quotes. Yep. This is in Python, so that's why I don't need the quotes. Actually, everything that's input into the URL is a string. So it gives me this thing right here. And to make a long story short, this thing that it's giving you is actually referred to as JSON. JSON stands for JavaScript Object Notation. The cool thing about JSON is that this format that it's written in is very similar, almost exactly the same as a component of as a data type in Python called a dictionary. This is a Python dictionary, can become a Python dictionary. Initially, this is just text, it's just characters. But if we want to turn this into a dictionary, we can use a statement called eval right here. And we'll go over dictionaries this week. So we can evaluate the data in this URL and return it into a variable. Okay? So all this code is doing is extracting the very first latitude and longitude. Sometimes if you type an ambiguous name like, let's say, Springfield, right? Springfield. If we type Springfield, notice that there are multiple results here. See, there's results that go all the way down the page. There's a bunch of them because there's lots of Springfields in the United States. However, there's only one Hattiesburg. In fact, even if we didn't write Mississippi, in fact, even if we don't even spell Hattiesburg correctly, Google is smart enough to figure out we're talking about Hattiesburg, Mississippi. Okay. All right. So the point here is that this function calls that web service. It's a web service. And that web service turns the text into a Python data type called a dictionary. And then it extracts from that the first latitude and longitude it encounters. So in other words, if you type Springfield, it's just going to get the first Springfield. It's not going to find all the Springfields, this function. And Google actually tries to figure out which one you mean. So if you just type Springfield, maybe it takes the one with the largest population. I don't know Google's logic, but in any case, that's what it's doing. And it returns that as a tuple. You can see here that it actually returns this as a tuple. So that's really all you need to know. You don't need to know how this works. It is fairly simple. It's only 4 lines of code, but you do need to know that it returns a tuple. Okay, a tuple. And so what we're going to do is write a function that turns our Hattiesburg, Mississippi, New York, Seattle, Washington. Instead of those values, it's going to return a tuple that represents, sorry, it's going to return a list of tuples. The tuples are going to be the data points. Okay, so we will do that together. Okay, so I'm going to call this, I'm going to create a function called get location list. And it's going to take my named locations, and it's going to, I got to say def, right? I'm going to define it, define my location list, and it's going to return the tuple, the list of tuple locations. That's what it's going to return. Okay. So how is it going to do that? Well, it's going to go through the cities, for city in cities. And it doesn't matter how we spell city, or even if we call it city, we could call it C. In fact, what we're going to do first, I'm just going to print city. That's what I'm going to do right now. File, save, run. Oh, I didn't call it. I didn't call that function. So I'm going to say get location list. It's going to be LL locations. That long locations. It's going to be get location list and cities. Run that. So now it's going to take this list. It's going to feed it into this function. And for right now, all it's just going to do is print out each item in the list. I didn't spell it right. It's going to print out each item in the list real quick. So Hattiesburg, New York, Seattle, Irvine. Printed each of those. Okay. All right. What I want it to do is return a list of tuple locations. So I've got to actually initialize that. I'm going to take my list of tuple locations, and I'm going to make that into a oh no, it's going to be a list. It's going to be a list of tuples. I'm going to make it into an empty list, And then each time through, I'm going to append into my list of tuple locations, I'm going to append the location. Okay. Now, all I need to do is find the location. So I could say something like this: location equals. Now I'm going to call that function. I got to copy it from GitHub. Take this function right here, copy it into here. All right, so I copied it into there, and I need to call that function with the city. And then I'm appending that on and returning it. So let's delete that. And we'll print these lat long locations. Now the code will call this function. In this function, it'll go through each city. It'll take each city and it'll get the address location for that city using this function. Now, by the way, to use the service for free, there's only a certain number of requests per day, but it's in the thousands. Okay, so don't worry about running it. But I guess if you did ever spend just a whole day in the lab trying to get the code to work, it would be theoretically possible to get to the limit where it would say this IP address is called this function too often. Okay. So I'm going to save this, run it, and notice that it took a little while. You saw the spinny thing on my computer there for a second. It took a little while to actually run this, and that's because it actually went out on the internet. What was it, 4 cities that I did? It went on the internet 4 times and got these values. This value, that's the latitude and longitude of Hattiesburg, Mississippi. This is the latitude and longitude here of New York, New York. This is the latitude and longitude of Seattle, Washington. And then this is the latitude and longitude of Irvine, California. Okay, so it called each of those functions in order, called this one, and then this one called this one 4 times within inside of it. Okay. All right, so what you have to do is, instead of using raw input to create your, or to run your program from last week, you need to modify it so that it creates a for list with this one. So you do something like for locations, for location in the lat long locations, and then say, do your magic or do your code here. Use stuff from last week. That's where you did it. So for right now, I'll just write print location. This is where you're going to input your code that will go through, and instead of having the user type out these latitude and longitude values, which is what it did last week, the computer is going to type those in based on the city's inputs. Almost smelled like something was burning there. Okay, so that's where you need to fill in the code. Let's look at the assignment again and see where we are. Week 3. Oops. And I'll upload these starters to the lab. So that's week 2. The function included in this lab uses a module to find the latitude and longitude, modify the program from last week to take a list of cities and report the distance along the path. So instead of you entering in coordinate pairs until you stop, you're going to modify it so that you enter a list. You have to add another city. You can add another city. You can make all the cities different, but you definitely have to add another city, and then you'll be done with that one. Okay. add another city, and you make it call the code from last week. So you have to cut and paste the code from last week into this week, into this week's lab. You have to copy that Habersign formula, and then you'll have to copy the code that you wrote that calls the Habersign formula. So for what you're going to do is for each time through, you're going to get the latitude and longitude, feed it into that Habersign formula, and it's going to return a length. And your function from last week should have taken the total of that length each time through the loop. First time through the loop, if the distance was 1,000 kilometers, it turned total into 1,000. Next time through the loop, if the distance was 8,000, it added 8,000 to 1,000, and that became the total, and so on. Okay. Now, if you look at the code from last week, you'll notice that it initializes the variable, and you still have to do that. You have to initialize the first time through the loop. The initial point has to be the first item in this list, the first tuple in the list. Okay. All right. So finally, the last one we're going to leave. We're going to leave open. This one is the one that you're going to have to try to do yourself, and feel free to ask me questions about it. But what you're going to do here is modify the script from the number 1 script. You're basically going to marry these 2 scripts. And so at the end, in addition to the total length, you're also going to calculate the mean and the standard deviation and the number of individual legs that were above a certain distance. So in other words, you're going to have an output that says your trip was this long. The average length of your individual segment trips, so if like from Hattiesburg to New York, New York to Seattle, Seattle, the average of those individual distances is this much. And then finally, you're going to also report, did I say report the standard deviation? Yeah, so you're going to report the standard deviation. And then finally, you're also going to allow the user to say, give a number like 1,000. And you could say, you had 2 legs that were over 1,000, or 1 leg that was over 1,000. Okay. All right. Now, a little bit of talk on strategy. You'll notice that as it stands, your code only calculates the distance between each segment, and then it takes those segments and adds them all up, and it doesn't store the individual segment lengths, does it? It doesn't do that. All of your functions from 1 actually take a list of numbers. And so strategically, what you need to do is instead of calculating the distance as you go through, create a list of all of the distances. Okay? So you create a list of all the distances, and then you create a list of all the distances, and you feed that list into the functions that you wrote for number 1, and then you'll be done. Okay? All right. So this lab should take a little bit more, head scratching to figure it out than last week. We left you with like 3 or 4 lines of code. This week, there's still probably not more than 20 or 30 lines of code. It's not a lot, but there'll be some cutting and pasting and kind of creating a Frankenstein examples. I mean, the Frankenstein script from a few of these scripts that you've built up so far. Okay. Does anybody have any questions about the logical flow of what the program needs to create? What is the deliverable? What do you need to create? Anybody have any questions about that as you've read it over? I'm going to go ahead and these are all saved. It looks like that's saved. That's saved. So I'm going to go ahead and make one more commit here. Starter scripts for lab 3 and commit. And now, if you didn't have a chance to, if I was typing too fast, now if you go to GitHub and you go here to week 3 and you refresh, you'll see those 2 starter scripts. See that? The There they are, and you'll have them all ready to go. All right. I'll leave the line open with the coast, and I'm here to help you as you start off on the lab. It is about almost about 8:30. I'll be here till about 8:30 when the time period's over, but I'll also be available by email to answer any questions, to help out on the lab. And if you have questions, let me know. I've uploaded it. I'm going to go ahead and stop the Google Hangout, and then just give me a few minutes here.